We're going to talk about a really important concept in programming called inheritance, and we're going to talk about it over two videos. So in this first video, we're going to just talk about the concept, like why would we ever even use inheritance? What problems does it solve? And in the second video, we'll get into coding. And to talk about inheritance, we're going to use virtual pets. So I have Tamagotchis pulled up here. They were a little toy that was egg-shaped that you could have a virtual pet inside of. You would feed it, you would give it medicine, whatever, and however well you took care of it would determine how long it survived. Pokemon, Neopets, there are a whole bunch of applications that build on this idea of virtual pets. So we're just going to use this as the topic to then talk about inheritance. So we're going to switch over to virtual whiteboard here. So with this idea of virtual pet, what we're going to do is, let's say we want to create this game world that, let's put some ground here. We want to create these goofy little pets in the world, and we're going to have a bunch of them in the world. The way that we've approached this before, and so this should hopefully be review, is we don't want to create a separate class for each of these in our game world. We want to figure out some ways to share code in efficient ways. So we'll create one class that will represent all of these little creatures, and we'll call that the virtual pet class. So going back to our UML diagram roots, we can create a giant box, 3 sections. So the top box is the name, virtual pet. The second box, these are our attributes. And attributes are the pieces of information, the variables that live inside of the class. And then down here we have our operations. And these would be the piece of functionality. So what can each virtual pet do in the world? So if we're thinking about attributes, we could go crazy. We could add a whole lot here, but let's just start with name, and that'll be a string. Type. So that might be like their species. So maybe it's dragon and rat and penguin that are the different types. Let's call that string. And let's add one more. Let's have weight, which will model as a double so that we can have fractional components to it. So when we create this in our class diagram with name, type, weight, that means that every pet in the world has a spot for name, type, and weight. So they can each have their own unique name, type, and weight. For operations, these would be what are the things that our pet can do. And maybe, we were just brainstorming, we want each pet to be able to sleep, we want each pet to be able to play, and we want each pet to be able to eat. So all of these instances of this virtual pet class in our world, we can call sleep, we can call play, we can call eat on them. So this that we just did here is actually called encapsulation. And encapsulation is a really important concept in programming. What it essentially means is that we took related pieces of information, our attributes, and related pieces of functionality, and we packaged them up together. So they live inside of this virtual pet class. It's just a logical way to organize them. The alternative, before we learned about classes, would just, we've got these 5 pets in the world. We'd have pet 1 name, that would be one variable, pet 2 name, that would be another variable, pet 3 name, that would be another variable. And we do the same thing. We'd have pet 1 type, pet 2 type, pet 3 type as just a bunch of loose variables in our code, not a ton of organization. And so encapsulation is an improvement on that, where we actually package things up using classes to create better organized code. Okay, so far, nothing new, hopefully. But let's say we've got this virtual pet, we've got a game, our players are loving it, but they have requested that we create some special types of pets. Some players want to be able to have a bird that can fly, and some players want to be able to have a fish that can swim. And so let's do a little goofy cartoony diagram here. So some players want a little bird, and some players want a fish that can swim. So we've got a couple of ways that we could approach this before leveraging inheritance. One is we could just go like this. We could add fly and swim into our virtual pet class, and now everything in the world can fly and swim, which doesn't really do exactly what we wanted. We really wanted just like maybe this pet over here to be a bird that can fly. We didn't really want everything in the world to be able to fly. So this isn't a great approach. So I'm going to kind of erase that. Another not great way to approach this would be we could just take our CS file for virtual pet, we can copy it to another file, we can rename it to be bird, and then we can add our fly method in there. And we can do the same thing for fish and add a swim method. Anytime we're doing copy and pasting, that usually means we're doing code duplication, and we want to avoid that. So there's actually a better way to approach this. So let's zoom out slightly. Make some room. So inheritance is a technique in programming that allows us to take an existing class and make a more specialized version of that class. So I can represent that in our UML diagram with an arrow. Down here, this will be our bird class. And let's say in our game, birds need to be able to fly. And so let's keep track of the fly speed as a double. And then we can add our method in here. And so by using inheritance, what we're doing is saying that the bird has all of the stuff from virtual pet. It has name, type, weight, sleep, play, eat, but it adds the fly speed and fly. So if we instantiate a virtual pet in our world, it won't be able to fly. If we do instantiate a bird, though, it will be able to fly in addition to sleep, play, and eat. We can do the same thing with a fish. So name it fish. We can do swim speed. I'm going to run out of room, so I'm going to put it on another line. That it's a double. And we've got our swim method. So same deal. Our fish is going to have name, type, weight, sleep, play, eat, but it's also going to tack on this swim operation, and it's going to add a swim speed attribute. If we wanted to, we could extend this even further, and we could make our tree bigger. So our bird here, we could create branches that come off for, let's say, dragon, or eagle, or penguin. And now how this would work is that we've got a dragon that's a specialized type of bird, and a bird is a specialized type of virtual pet. So our dragon actually gets everything from bird and from virtual pet. So the dragon can fly, it can also eat, play, sleep, and then we could add our own extra operations and attributes that are dragon specific down here. If you wanted to go even further, you could create a specialized set off of dragon. So we could have an ice dragon and a fire dragon. And you could create specialized versions off of those, and you can go really far with creating deep inheritance trees like this. Forgot my arrow in here, so making sure to put my arrow in. So let's talk about terminology for a second. We've been saying specialized and less specialized, but actually the terms that you'll usually see are like base class, parent class, superclass. These refer to the less specialized class. So in our case, our virtual pet is our base class, it's our parent class, it's our superclass. These are just synonyms for talking about the same thing. You'll encounter different textbooks, different videos will talk about them using different terminology. So then in terms of our fish and bird, we call this the derived class, child class, or subclass. And so what you'll usually find is that if someone is referring to a base class for the less specialized class, they will then say derived class when talking about more specialized classes. And same thing, parent goes with child, super goes with subclass. And in terms of UML diagrams, now that we've used these names, let's create a rule here. When we are diagramming UML, our child class is represented in a box, our standard UML box, and then we use an arrow pointing towards the parent class. So when you're doing your UML, say for your adventure game or for some other project, and you're modeling inheritance, you want to use this structure where the child has an arrow pointing to the parent when you're representing inheritance. When we're talking about inheritance, we usually talk about it as an is-a relationship. So is a blank. So when we're talking about our virtual pet and our bird class is a more specialized type of virtual pet. And as a sneak preview of some stuff we'll talk about when we get into code is that there's another type of relationship called a has-a that has a similar structure. And so let's take our bird again. And a bird could have a toy. So has-a is a different type of code relationship than inheritance. We wouldn't use this inheritance structure that we're talking about to model the bird and toy class. But if the things that you're modeling in your world happen to fall into this is-a relationship, where bird is a virtual pet or fish is a virtual pet, that is often a clue that inheritance might be a good fit for the problem that you're trying to solve. So let's review. What we started off doing was talking about virtual pets and some stuff that we've done before. We did a class diagram for a virtual pet. We used encapsulation to take related pieces of data and related piece of functionality and model them together in a class. Where inheritance came in was we ran into the situation where we have a virtual pet, it's working great, and we want to create a specialized type of a virtual pet that can fly, which was our bird, and we wanted to create another specialized type that could swim. We didn't want all virtual pets to be able to fly, and we didn't want all virtual pets to be able to swim. So we used inheritance as a code sharing technique so that we could create a virtual pet class, and then we could have a bird that gets everything from virtual pet and is able to tack on some new attributes and some new operations. We will see what this looks like in terms of code. We'll go ahead, we'll make a virtual pet, we'll make some specialized types, and this will start to make more sense. One thing I want to leave you with as we're talking about inheritance is that it is one strategy to solve this problem that we're running into of we've got something in the world, a virtual pet, and we have some specialized versions where we want to be able to share code from virtual pet to bird or share code from virtual pet to fish. This is not the only technique. There are other techniques to do it. It is just the technique that we're talking about this week. As you take more programming classes, you will learn other strategies for modeling and solving these types of problems. So I'll see you in the next video where we will go ahead and actually implement this in a C# project.